Okay. Let me start talking a little bit about box and pointer diagrams. This thing is called a box and pointer diagram. The pairs are the boxes and the arrows are the pointers. And one of the things we want you to be able to do is draw these diagrams either explicitly in response to a question, like draw the box and pointer diagram for such and such, or to help you answer a question by really understanding what a data structure looks like. So here's how we draw a box and pointer diagram. Let's draw the box and pointer diagram for this. Okay? List. First thing I'm going to do is I'm going to count elements. 1, 2, 3, 4, 5, 6 elements. Okay? Not elements of elements, just elements of the whole list. So since there are 6 elements, I'm going to go ahead and draw the spine of the list. Here it is. Okay? First step. Did I get it right? Yeah. Okay. Now I can start filling these in. It doesn't really matter now what order I do it in, so I'm going to start with the easy ones. A and 7 are elements of this list. How about the empty list? Well, when we have an empty list as a piece of a pair, we just put a slash through the corresponding path. So usually you see a slash, as in this pair, in the cdr of the last pair of a list, but this time it's in the car because the empty list is an element of this list. Okay? All right, now let's do 3, 4. That is itself a list of length 2. So I'm going to go ahead and draw its spine, length 2, and then fill in the elements. 3, 4. How about this? How many elements? 2. Second element is just W. The first element is a list of length 1. So here it is, a spine of length 1, in which I'm going to put a B. And last but not least, this is a list of length 1. And its one element is this list of length 1. One more. Okay? That's how you do it. Basically, start at the top, draw the spine first, work your way in. Okay. So some crucial little details about box and pointer diagrams. First little crucial detail is this thing. This is called a start arrow. And it's really important to have one so that we can tell where the beginning of your diagram is, especially when they get complicated and things kind of wrap around all over the place. So start arrow, don't forget. Secondly, most important of all, there is no such thing as pointing to half of a pair. So this arrow, for example, is not a pointer to the car of this pair. Even though it happens to come in at the left, it's a pointer to this entire pair. Okay? If you wanted a pointer to the car of the pair, that would be this. This is the car of that pair. It's the thing that this arrow points to. Okay? So no such thing as a pointer to half of a box. Yeah? What if he's asking, you're pointing to a box that has a slash on the right? There's no such thing as pointing to half of a box. This arrow points to this entire pair. Okay? Okay. What else? Huh, that's it. Okay, questions? Yeah. Great. What can go in a list? Answer, anything. Yes, procedures can be elements of lists. Lists can be elements of lists. True and false can be elements of lists, right? And furthermore, even one particular list can have some of each of those things. So lists don't have to be homogeneous. Yeah, that's the nice thing about lists. They can have absolutely anything you want in them. Okay? Other questions? Yeah. Okay, the difference between append, list, and cons again. Cons is for the situation in which you have a list and you want to add one new element at the front. So you can think of it as a join, new element, old list. List is you're making a fixed length list and you're explicitly saying what each element is. Boom, 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 boom. Append, you have a bunch of lists and you want to put them together, but you don't want a list of lists as the result. You want a list of the elements of the lists. What if those elements are actually lists? That's fine. It doesn't flatten all the way down. It just takes the elements of the list, whatever they are. Okay?